We now discuss the solution of a problem based on the concept of the counting from the section Permutations and Combinations. This question has appeared in the Joint Entrance Examination Main held on 25th January 2023 in the first shift. The given question is, let S be a set consisting of the elements 1, 2, 3, 5, 7, 10 and 11. The number of non-empty subsets of S, that have the sum of all elements a multiple of 3 is. We are given a set S consisting of the elements 1, 2, 3, 5, 7, 10, 11. Required to find the number of non-empty subsets of S whose elements when added is a multiple of 3. So, how many such non-empty subsets of S are there whose elements when added is a multiple of 3? That is our given question. We now discuss the solution of the problem in detail. We have S, the set consisting of the elements 1, 2, 3, 5, 7, 10, 11. Let's first of all see, we take the S itself. S is a subset of itself. Yes. When you add the elements of that, and it is a multiple, it is a 39. 1 plus 2 plus 3 plus 5 plus 7 plus 10 plus 11, it is 39, and which is a multiple of 3. Right. That means S is one candidate for in the number of non-empty subsets of S with that property. Agreed. One of them. And the other one, I can easily see that a singleton set consisting of 3. That's also a subset of that, and whose elements when added is a multiple of 3. So let's see. 3, singleton 3 can also be a candidate, right? 1, 2, subset consisting of 1, 2. When added, it is 3, which is a multiple of 3. That's also a subset. And 1, 3, 5, the subset consisting of 1, 3, 5. When added, you will get 9, which is a multiple of 3. Is also one of the non-empty subsets what is required. And the set consisting of 4 elements 2, 7, 10, 11. So it is 21 plus 9, it is 30, which is a multiple of 3. Like that, you have to enumerate all of them and say how many non-empty subsets of S are there whose elements when added will give you a multiple of 3, etc. So the question is how many? So for that, let's go and discuss the problem. So first I will consider S suffix I. Let S suffix I is equal to the set of all those elements of S when divided by 3 gives the remainder I. That means is the set of all those elements X belongs to S such that I is the remainder of X when on division by 3. That means X belongs to S such that X is congruent to I mod 3. In number theory aspect, we say like that. So first we say S0. S0 means 0 is the remainder of X on division by 3. What are those elements in this? There is only one element, that is 3. That is 3. Next is what are those elements when divided by 3 gives a remainder 1. 1 is a candidate. Yes. 7 is a candidate. And 10 is a candidate. Correct. So S1 consists of 1, 7, 10. So then S0 is the singleton set consisting of 3. S1 is 1, 7, 10. You can see on division by 3 gives the residue, the remainder 1. And S2 is all those elements when divided by 3 gives remainder 2. So 2, 5, 11. So now this S is partitioned into 3 sets. 3 sets. Agreed. Notice that x plus y belongs to is a multiple of 3. For all x belongs to S1, y belongs to S2. That means you take one element from S1 and one element from S2, add, it is a multiple of 3. For example, you take 7, there is 11, 7 plus 11, 18 is a multiple of 3. Like that. That means you take one element from S1, one element from S2, add, is a multiple of 3. That means so how many subsets you can get? One element out of 3 multiplied by one element out of 3, that is 3C1 into 3C1, that is 9 subsets you will get. 9 subsets you will get. And suppose you want to see, for example, 1, 2, one candidate, 1, 5, next 1, 11, like that you take consider all those subsets consisting of 2 elements. So they are 9 in number. Further, you take W plus X plus Y plus Z is a multiple of 3 for all WX belongs to S1 and YZ belongs to S2. That means you take any 2 elements here and any 2 elements here, add is a multiple of 3. For example, 110, 2 elements here, there 511. So 110, 511, which is a multiple of 3. Agreed. So how many such things you will get? So that means you have to choose 2 elements from S1. That means out of 3 elements, you choose 2 elements. That means 3C2 multiplied by 3C2. And 3C2 multiplied by 3C2 is again 3C1 multiplied by 3C1 is again, which is 9. Anyway, so now see, get into S1, add all the elements of S1. 1 plus 7 plus 10, it is a multiple of 3. Add all the elements of S2, 2 plus 5 plus 11 is a multiple of 3. So that's what it says. X plus Y plus Z is a multiple of 3 for all X, Y, Z belongs to S1 and so also for S2. Now let us, because now we have to count, so let n suffix k be the number of non-empty subsets of S having k elements. So nk is the number of non-empty subsets of S having k elements such that the sum of its k elements is a multiple of 3. So nk is the number of non-empty subsets of S having k elements such that the sum of these k elements of that subset when added is a multiple of 3. So we will now enumerate the number of all non-empty such subsets in the next slide. Agreed. So now remember, S0 is the singleton 3. S1 is a set consisting of 3 elements 1, 7, 10 and S2 the set consisting of 2, 5, 11. Agreed. Now we will make a tabular form. So the first column is k elements, 1 element, 2 element, 3 elements, like that. So how sets, we form the sets here. Nk, how many subsets are there? Nk. So for example, k, we will start with 1. 1 element, how many subsets are there whose element, which is a multiple of 3, is only 1 element, that is S0 only. And nk will be only one subset, nk is 1. So let us take 2 elements. So that means the set consists of x, y, where x belongs to S1, y belongs to S2. We have already seen any one element from S1 and any element, any one element from S2 when added is a multiple of 3. So x is from S1. That means how many ways you can select one element from S1. So 3 elements, out of 3 elements choose one element, 3C1, and here also 3C1. So 3C1 multiplied by 3C1, that is 9. And how many, so now k is 3 elements. 3 elements. How many subsets are there having 3 elements? When added, their elements is a multiple of 3. So the set of subsets x, y, z. X belongs to S0, which is a 3. Y belongs to S1, one of them. Z belongs to S2, one of them. So 1 of S1, 1 of S2 is a multiple of 3. And an element of S0 is again a multiple of 3. The sum is a multiple of 3. So not only that, S1 is a set with the 3 elements. When added their elements is a multiple of 3. So S1 is also a candidate. So this is, the students normally make a mistake. They do up to this, they forget about S1 and also S2. So S2 is also a candidate. So from here, X belongs to S1. That means one element from S0. So there is only one C1 multiplied by one element from S1. That means 3C1. And one element from S2, 3C2. 1 C1 multiplied by 3C1 multiplied by 3C1. S1 is 1. S2 is another 1. So it is 9 plus 1 plus 1, that is equal to 11. Now, having 4 elements. So take W, X, Y, Z. Now take any 2 elements from S1. You add any 2 elements is a multiple of 3. Any 2 elements from S2 is a multiple of 3. Multiple of 3. So that means 2 elements out of 3 elements from S1. That is 3C2 multiplied by 3C2. Not only that, S0 having one element, S1 is having 3 elements. When you take a union, S0 union S1 consists of 4 elements, but when you see add their elements, it's a multiple of 3. So also S0 union S2. S0 union S2. So from here, so you will get what? 3C2 cross 3C2. This is 1. S0 union S1 is 1, having 4 elements, whose elements when added is a multiple of 3. Like that, S0 union S2, 1 plus 1, you will get 11. Now, having 5 elements, V, W, X, Y, Z. V belongs to S0, one element is from S0, and 2 elements from S1, and 2 elements, any 2 elements from S2. So, if you see, any 2 elements from S1 and any 2 elements from S2 when added is a multiple of 3, and to that 3 is added, one element of S0 is added, then is also a multiple of 3. That means one element from S0, 2 elements from S1, 2 elements from S2. So you will get what? So 3C2, 3, any 2 elements here, 3C2 cross 3C2. Of course, you can write 1C1 also. Plus 1, 3, no, sorry. This is 1C1. V comes from S0, 1C1. 2 elements from S1, 3C2. 2 elements from S2, that is 3C2. This is 9. Agreed. And 6 elements, having X elements. Now, S1 having 3 elements, S2 having 3 elements, union you take S1 union S2, and when added the elements is a multiple of 3. So therefore, there is only one. Only S1 union S2 together, you have to do 6 elements you have to consider. So it is one set, one subset only. 7, all the elements, S0 union S1 union S2, that means the whole of the set S. And we have already seen that when added their elements is a multiple of 3. Therefore, with the 7 elements, you have only one subset, that is the whole set. That is 1. Now, the counting is over. So, the whole set S has 7 elements, and you can have subsets with 1 elements, 2 elements, 3 elements, 4, 5, 6, 7. These are the only. And the number of subsets we have already counted here. The answer is the total number of subsets. You have to add all of them. Add 1 plus 9 plus 11 plus 11 plus 9 plus 1 plus 1. When added, you will get 43. the number of non-empty subsets of S that have the sum of all its elements is a multiple of 3 is 43. So that is the detailed discussion of the solution of the problem on the concept of counting from the section permutations and combinations. It is an interesting question, and it is a moderately difficult question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.